In this lab, we're going to go through and finish the Jupiter's moons activity. So in part one, you went through and made your measurements of the position of Jupiter and each of its 4 largest moons in the images that you were assigned. Then you calculated the distance between Jupiter and each one of those moons and submitted all of these measurements in a Google form. So I've now collated that Google form and sorted out the data for each of the 4 moons into 4 different data sheets. One for Io, one for Europa, one for Ganymede, and one for Callisto. All of those files are already preloaded into this website CoCalc that I'm getting ready to show you. So first I want to show you how to get to where you need to get to in CoCalc, and then we'll start stepping through the activity itself. So when you first log into CoCalc, you should see something somewhat like this, although I've already entered our assignments folder. Once you go into assignments, you'll see the Jupiter project folder. Enter that one, and now you'll see the Jupiter Lab file and the 4 data files that I just mentioned, Io, Ganymede, Europa, and Callisto. And this last one is a due date file, but you already know what the due date is. So we're going to open this Jupiter Lab file first. Alright, so now I have both the instructions, the lab manual for this particular lab, and the CoCalc program open at the same time. So you're going to want to go through and follow the instructions in CoCalc while answering the questions in the lab manual. Before you get started with either of these, make sure you answer question 1 and 2 first. Then number 1 here starts to tell you how to go through and log in, find the email, etc., etc. So within this is a Python program, but it's a Python program that we are allowed to write various instructions inside of it as well. It's known as a Jupyter Notebook. No relation to the planet Jupiter. So when you're going through and looking at this, you'll want to go through and read the instructions inside of here. And everything I tell you is going to be in the instructions themselves. So this paragraph right here tells us that if we want to run some code, and you can tell that it's code because it's inside this rectangular box and it has the in and square brackets right in front of it. If we want to run one of these, we need to click inside of it, and it actually doesn't matter where you click, it can be anywhere. And you're going to press Shift and then the Enter key. And that then runs it. So you saw that it flashed up an arrow and then a green circle, and now it has a number 1 inside of it. So that means that we did go through and run that particular snippet of code. Now, that specific snippet of code means ran, but there was no output to it, so we don't see anything other than the fact that a number appeared inside those square brackets. That's what tells us the code ran. So as we go through and work ourselves through this, through the instructions here, you should go through and read it. They're going to give you information on what you should be trying as you go through and test these. But essentially, this is a computer program that we've already written that includes almost all of the information you need. And I'm going to show you how this works for Callisto, because Callisto is the one that we've given the initial guesses for. And then it'll be your job to make initial guesses based on what you see moving forward. So I've given you what the initial guesses should be here. And you can see they're already actually written into the code. So there are these first 3 lines here. Don't go through and touch anything else inside of here. You don't want to be changing any other numbers. If you do, you can always go back and revert and undo what you've done. If you do happen to mess something up, that's fine too. And if things get really messed up, let me know and I can go through and fix it, because I can log in and see everything that you've done and make any corrections as needed. So we're going to go through and run this snippet of code. Again, it doesn't matter where we put it. And you can see this time we get an output. So what this program is doing is it is going through and taking our file, our data file that has all of your measurements inside of it, and it's going through and trying to fit a curve. So I've written a little program here that fits a curve, and it fits a curve based on our 3 initial guesses right here. So our guess is guessing what the radius of the moon's orbit happens to be, so Callisto's orbit in this example. Period guess is your guess for what the period is, and then offset guess is the guess of the offset. So for example, a normal cycle would start down here at 0, and it's how far offset you are from that. because we don't necessarily expect that when we happen to start taking measurements that it was right next to Jupiter at that moment in time. So this blue dashed line is our model fit. So this is what the program is saying is the absolute best fit to the data. Now in the best case scenario, we would have all of our little red data points. Each of those red circles corresponds to some of the measurements that you all or your classmates took. We want to have as many of those along this curve as possible. And you're going to answer some questions about why some of these dots don't fit that curve. But the best possible fit will be something that follows along this curve here. So your job is going to be to try and make guesses that allow the program to figure out what that best fit is. So we guessed an initial guess of 1200 or 1200 pixels for the initial radius, and it came back and told me that the fit of this, that fits this data the best and makes this curve match those red dots the best, is 1175. So not too far off. The period here is 16.5 days, and that offset is 0.69 days. So again, that's not too far off from what our initial guess was here. Now, of course, I know what the answer is, and that's why I could give you some good initial guesses. And so I wanted to show you how this worked. But you can go through and you can change these. Maybe I thought the initial period should be 20, and I thought the offset guess should be 2, and I could make this 1500. I can run it again if I want to. That's fine. The program's job is to try and use my guesses to fit as best as possible. So here's an example of my guess led to something that it thinks is fitting it, but isn't doing a very good job. So as you move through some of the other moons, I will be giving you some of the pieces, but it's your job to go through and figure out what the other pieces are. And so you might have to play around with this a little bit to try and get things closer. Another thing that you might be able to look at is by looking at where the data points are, you might be able to try and get a guess. So for example, if I've got a bunch of data points up here, remember some of these are outliers. But if I have a bunch stuck like next to each other in these clumps, then I can probably believe those since each of those images was measured by a different person, which means that my final radius here, our final, needs to be at least as big as that when I'm going through and guessing, and probably close to the furthest ones out. So that's where that initial guess of 1200 came from. The next thing that you want to consider is the period. So you can almost tell sometimes from looking at these how big that period might be. And so this piece of data right here might be a good guess. And there may be multiple curves in here. You don't really know. Maybe we missed a bunch of days or something, and so you might see something like that later, but I can still get a rough guess to give me a try. And then the offset, you just have to go through and try a bunch. It's not super easy to look at the data unless you've really gone through and done this lots of times to get used to be able to make those kinds of guesses. But our initial guess of 16 something days, well, that's not too far off from this 10 days to around here. So let's go through and update this again. I mean, I purposely threw them off. Let's make this 1300 and we'll make this, say, 17 and see if we can get something any closer than what we got last time. So you can see we've gotten something much closer than what we had last time. In fact, our final and the period are essentially the same as what we got last time. The offset is different, and that's okay. Again, the offset is just some random offset. We don't need to focus on it. The things we really care about are our final and period final. So hopefully that gives you a rough idea of how you're going to go through and do this. So once you have those initial numbers, you're going to enter them into your final Callisto fits. Make sure you include the units. I did mention what those were. Use this graph to answer the questions in number 3. So you're going to go through and do the same things for Europa and Ganymede and Io, but make sure you follow the order both in CoCalc and in the instructions itself. So Ganymede is next, and I'm giving you a guess at least for the radius. So and that's based on the measurements that you went through and did. So I went ahead and put that guess in there. And you're going to want to go through and take a look at things and give it a guess for the period, and then of course give it an offset. And I'm giving you not a perfect guess, but I'm giving you some hints through here. So make sure you're reading through the text for your initial guesses. You'll want to record what your initial guesses are, and then your final values as well. And again, if your graph when you get it out doesn't look super great, it's going to look more clumped up together than this. Callisto has one of the largest periods, so therefore it's far away from Jupiter. So these curves are going to end up getting skinnier and skinnier, so it may become harder to see. But you'll want to go ahead and record your final values that come out when you enter this as well. Same for Io. So again, I'm giving you a little bit of a hint in here, but now you have to come up with your own 3 guesses to start out with, and then record your final values. Once you've gone through and got good-looking graphs and final values for all 3 of those moons, then you're going to go through to the lab manual itself, and you're going to use this highlighted formula to calculate the mass of Jupiter. So what I've done is this formula up here is a combination of Kepler's laws and Newton's law of gravity. And I've essentially already done the algebra for you to solve this for the mass of Jupiter. So this is the only formula you need to use, but I wanted to make sure you understood where it came from, not that it just came out of thin air. So you will plug in your semi-major axis here in pixels. That is the R final. And your period in days. So that's the period final. You're going to do this for each of those 3 moons and record the mass that you calculate down here. Make sure you show your work up here. You won't earn credit without showing that work. And then you'll average the 3 of those guesses to get an average mass of Jupiter. In question 5, you're going to compare your average mass that you calculated using our measurements to the accepted value of roughly 1.9 times 10 to the 27 kilograms. And here is a formula that you'll use to figure out the percent difference. So you'll put your value in here, subtract this accepted value, divide it by the accepted value, and multiply that by 100. Make sure you remember to put parentheses around anything in the denominator, so that's this entire full number, or else your measurements, your calculation will come out incorrectly. And then you'll plug your answer. You'll write down your answer for percent difference there. Some questions about how your answer compared. And then finally, when you get to questions 6 and 7 to finish the lab, we're going to continue on, and now we're going to take a look at Europa. So that's the very last bit. But make sure you do questions 4 and 5 before you do that, because you're essentially going to use your results from those to come up with a guess for what your guesses for Europa should be. Then you'll go through and test them and answer some final questions in question 7 here. So that's the extent of Jupiter's moons part 2. A few hints and tricks. If you're running into any issues with things, you'll want to make sure that you reach out to me on Slack as soon as you have any problems. Don't spin your wheels for an hour or more if you're running into some sort of problems. One of the most common problems, and I'll make sure that this is inside the Canvas assignment as well, is if you let things sit for too long in CoCalc, it kind of goes to sleep, so to speak. And so even though I've already run this part up here and I've run some other stuff, what can happen occasionally if you let it sit, or sometimes it just resets itself. But I want to show you an error that you can sometimes get and how to go through and fix this, because it's actually very easy for you to do yourself. Okay, so let's say you're going through, getting ready to run some code, you do your Shift Enter, and then you get an error that looks like this. In particular, the thing that I'm looking for is what's listed down here at the bottom where it says name NP is not defined. 99% of the time what this means is something reset, and so you need to rerun this very first one again. So if I run this one again, and again it doesn't show me any output, but I can see that I've got a little number in that box there, and that number has updated, so I know that it's run. If I do that and then come back to the one that I was trying to go through and do, then you can see the problem is fixed. So If you run into that error at any point in time, make sure you just go and rerun that very first snippet of code, and then you can go back to whatever it was that you were doing before. So that should solve most of your issues when you're going through and doing this lab. When you're done, you'll submit this lab manual in Canvas. And again, I will also go through and check your results in CoCalc itself. But I can do that without you submitting anything. So let me know if you have any questions, and good luck.